The picture shows various topics related to risk management that came with the climate change that the Canadian government has to deal with as a unit. Climate change in the next 20 years will impact the average Canadians in every foreseeable fashion. Instead of discussing the matter through an ecological standpoint, I want to focus my spotlight on physical infrastructures. Since I'm a civil engineer, I want to explain some complications that come with the climate change in the civil engineering perspective, i.e., physical infrastructure risk. After all, average Canadians' daily lives will most likely be interrupted if our major infrastructures fail or require long-duration upgrade to combat weather conditions. To put the issues into perspective, imagine multiple Highway 401 concrete bridges need emergency repair due to extreme freeze and thaw. How many lives will this event influence? This is one example, discussed one environmental factor and its effect on one highway. If climate change becomes severe in the next 20 years, it will no doubt inflict damage to every Canadian infrastructure. From a design point of view, many Canadian buildings and municipal hydraulic systems are designed with a 15-year return period for each weather condition. For rain and snow, it means the structures would have the ability to handle most torrential downpour and snow accumulation of the corresponding weather condition with a return period of 50 years. It is easy to spot the correlation between weather and construction plans. Between 1948 and 2016, the annual average temperature in Canada increased by 1.7 degrees Celsius. It is twice the increase for the Earth as a whole. The temperature change will induce atmospheric circulation, storm track, hence Canada will experience a more active hydrological cycle, more frequent and intense precipitation events. An extreme snowstorm will create a more massive snow load that our buildings are not designed for, which will strain steel frames on roofs. Extreme wind will give buildings a more significant wind load. If not calculated properly, it will create torsion forces that building columns cannot hold. Keep in mind that skyscrapers are always moving due to constant wind forces. People do not notice the movement because engineers design buildings with specific wind load factors in mind. Imagine these factors cannot keep up with rapid climate change. Underground infrastructure will also be strained if the unanticipated precipitation continues. Rainfall runoff is typically transported through snowstorms designed with a 50-year storm. Heavy rainfall with intense frequency will have a high chance of paralyzing city sewers. Hence, the system will not have the ability to dewater urban areas. Flooding will cause damage to homes, vehicles, etc. With more intense climate changes, existing infrastructures are not designed adequately for future challenges, and the consequences are already showing today. In 2016, Canadian insurance industry paid 200,000 claims worth a record $4.9 billion for property damages associated with weather-related events. Climate change will impact the average Canadian in the next 20 years through risks to physical infrastructures. Thank you.